Hi, my name is Henry Conde, and this is my FEC1 synthesis project. In this project, students are expected to answer the question, what does it mean to be a disciplinary engineer, by synthesizing information about how we see ourselves in our chosen discipline of engineering. Engineering is a field of study that applies math and science principles in order to solve problems, invent, design, and build. Some specialized disciplines of engineering include civil, mechanical, chemical, and electrical. My chosen discipline is electrical. Although sometimes it could be challenging, my job is to make it less frightening for the students entering this discipline. What is electrical engineering? To answer this, my main focus will be the origins of electrical engineering. It's hard to say exactly when this discipline started, but some would say the 19th century, around the time of the telegraph. Michael Faraday, born in 1791, was known as the father of electricity, born outside of London, England. Michael Faraday was never really introduced to schooling, but had basic reading, writing, and math skills. He was also a self-taught physicist and chemist. Faraday is known for his discoveries of electromagnetic induction and laws of electrolysis. Faraday's law of electromagnetic induction, also known as Faraday's law, is a basic law of electromagnetism predicting how a magnetic field will interact with an electric circuit to produce an electromotive force. Faraday created the first transformer in August 1831. Soon after, he invented the first electric motor. Some of the pioneers in electrical engineering, like Alexander Graham Bell, started as telegraph operators. Bell was born in Edinburgh, Scotland in 1847. In 1871, he began to develop an upgraded telegraph machine capable of sending and receiving messages at the same time. Bell's work inspired others, including his electrician partner, Thomas Watson. Working together, Bell and Watson developed the first voice-transmitting device. One could think of their efforts as the foundation work for today's cell phones, televisions, computers, and other essential electronic devices. Thomas Edison was born in 1847 in Milan, Ohio. Edison is arguably the most famous of all engineers in history and is known as America's greatest inventor. As a young child, Edison spent many hours working on experiments at home. He suffered hearing loss due to scarlet fever and may have exhibited signs of ADHD according to today's medical definition. His career began as a telegrapher at age 16. At age 19, he moved to Louisville, Kentucky to work at the Western Union. Edison's first invention was the electric vote recorder, patent granted in 1869, but the invention was not very successful. Edison eventually moved to New York City and lived with one of his mentors, Franklin Leonard Pope. In 1869, Edison and Pope started their own business as electrical engineers and inventors. In 1874, they began working on the multiplex telegraph system. With the proceeds from the sale of the multiplex telegraph system, Edison funded the Menlo Park Research Lab, where Edison and his team worked on most of his inventions. There, Edison's team experimented with the telephone, the phonograph, the electric railway, the ore separation, and many other inventions. On December 31st, 1879, Edison first demonstrated the incandescent light bulb invention. However, Edison's patent was ruled as the work of William Sawyers. After years of litigation, Edison's electric light bulb filament was finally validated on October of 1889. Over his career, Edison holds 1,093 patents, most of which were utility. Another individual in the field of electrical engineering, and the nemesis of Thomas Edison, was Nikola Tesla. Tesla was born during a severe lightning storm in Croatia in July 1856 and immigrated to the US in 1884. Tesla was known to have a photographic memory, vivid imagination, and a great sense of humor. However, his contributions to electrical engineering were not fully appreciated. In the 1880s, there was a war of currents between Thomas Edison and Nikola Tesla over which of the electrical generation systems would eventually power the world. Tesla had a brilliant mind, but was not good at bringing his ideas to practice. Eventually, he sold many of his alternating current patents to his chief business partner, George Westinghouse. The next topic I will talk about are professional organizations. The three largest or most important professional organizations in electrical engineering are the Institution of Electrical and Electronics Engineers, the International Society for Optics and Photonics, and the Institution of Engineering and Technology. In this project, I'll focus on IEEE. It was founded on January 1st. It has the world's largest professional association, and it believes in advancing innovation and technological excellence for the benefit of humanity. Three subdisciplines of electrical engineering include, but are not exclusive to, power engineering, signal processing, and control systems. Power engineering is the subdiscipline that finds ways to generate and distribute electricity. Signal processing is the subdiscipline that finds ways to process, display, and track data, usually with the use of devices, and control system finds ways to create and improve on systems. Electrical engineering has a wide display of common applications, some of which include renewable energy, sensors, computers, and cell phones. Current challenges include green power generation, power storage, and electric car technology. For my engineering role model, I decided to choose Mario Conde, also known as my brother. Some of my brother's notable accomplishments is that he has been with the same company for 5 years, he was a volunteer for the ACE Mentors program, and he was a previous student in the Rowan ECE program. He works for Atlantic City Electric as a distribution systems operator. Through this engineering synthesis project, I reflected on how I see myself in the discipline, I accepted the challenges of the program, I better understood the importance of facing and overcoming failure to become an electrical engineer, I gained an appreciation for the origins, important people, and organizations within the discipline and past, present, and future implications, and I hope to educate and inspire the students pursuing electrical engineering. What I've learned from origins is that electrical engineering is a relatively new field of engineering. Early electrical engineers formed ideas that established the foundation for the field as we know it today. Origins influenced modern-day tools such as computers, cell phones, smart home technology, and many more. Many of the individuals who were important in the field were not necessarily typical students. They didn't have any formal education. They enjoyed learning, experimenting, and problem solving. They had physical or learning disabilities or struggled with focus, as I could relate to. They gave me the importance of overcoming adversity, and I had a better understanding for the importance of failure in the learning process, and I gained a better appreciation for the field I am pursuing, electrical engineering. What I learned from completing organizations is that professional organizations are important in guiding the discipline of electrical engineering. I personally participated in IEEE. I'm currently the workshop chair of IEEE. I participated in the SumoBots competitions. It's a really fun and social environment, and it stresses the importance of healthy competition and motivating me to learn. It also taught me the value of being involved. As a result of completing current implications, I better understand how the past discoveries and inventions have formed the foundations of today's technology. The field of electrical engineering has important applications in green energy, power storage and distribution, electric vehicles, smart homes, medicine, and virtually every aspect of today's life. This inspires me to overcome the challenges of the ECE program to make a positive contribution in the field for the future of the design, construction, or utility industry. After completing the engineering role models, I learned that early engineers all had someone who served as a mentor or a role model for them. Individuals who had the most influence on me were the ones that directly impacted my life. A couple of honorable mentions for my role models are my engineering teachers during my CC Tech program and those involved in the ACE Mentors program, along with my brother. My brother attended the Rowan University ECE program and now works as a distribution systems operator for Atlantic City Electric after serving 5 years of internships through his time as a student. Seeing my brother's accomplishments has inspired me to follow in his footsteps. My brother serves as an alumnus volunteer for the ACE Mentors program, and I am currently doing so as well. Thank you for watching my presentation. The following is the works cited.